So folks, this video is going to finish up our overview of logarithms, and what I want to focus on in this video is the properties of logarithms. We're going to see that those are related to the properties of exponents. I'm asking you to first watch this video on the history of logarithms, so take a look at it and answer the first question, and then let's jump into the rest of this together. So let's go ahead and state the product sum properties for logarithms. So if we were to take the log of m times n, this is equal to the log, let me put a base there, log base a of m plus the log base a of n. So we'll remember this property as saying that multiplication inside the logarithm is equal to addition outside the logarithm. So this is true whether I'm using natural log or another base for logarithms. But if I have a product inside my logarithms, I can break that product up over the logarithms if I express them as a sum. And I think it's worth pointing out that this is sort of the inverse property. If you have a to the m times a to the n, here we have multiplication outside of two exponents, and that's equal to a to the m plus n, and we've got addition inside of a single exponent. And in my opinion, there's sort of a mirror image in this property here that I'm giving you, that when we have multiplication inside of a logarithm, it's equal to addition outside of a logarithm. Okay. Let's do the same thing with a division or difference problem. So if we have the log base a of m divided by n, that's equal to the log base a of m minus the log base a of n. And again, this seems reminiscent of our properties, or sort of an analog to our properties of exponents, where if we were to take a to the m divided by a to the n, that's equal to a to the m minus n. And here we have division outside of an exponential expression is equal to subtraction inside of it. We have basically the obverse property here, where division inside the logarithm of a base is equal to subtraction outside that logarithm. We remember this as division inside is equal to subtraction outside the logarithm. Okay. So let's continue. Let's go give this last property here. This is the power factor property for logarithms, and it says if we were to take the log base a of m to the r power, this is equal to r times the log base a of m. Okay. And there's an analog there here. We'll just go past it though. We'll remember this property though as powers of arguments of logarithms come out as factors. Okay. I do want to warn you on this one, the entire argument needs to be raised to the rth power. So for example, if we were to have the log base 2 of x squared times y, I can't at this moment bring that power of 2 outside of that logarithm. But if we had the log base 2 of xy squared, now the entire argument is being raised to the second power, and we can rewrite that as 2 log base 2 of xy. Okay, so what we're going to do now is we're going to rewrite a number of these expressions. I'm going to leave you to write some on your own, but we're going to rewrite a number of these expressions using the properties of logarithms. And right now, please don't think of this as something that you always have to do when you see a logarithmic expression. Right now, what we're doing is we're just trying to get practice using these 1, 2, 3 log properties. We're just trying to get practice with those log properties. So in this case, we've got the log, what base is that, folks? That's the log base 10 of 5x. So if we have log base 10 of 5x, one thing you're allowed to do, and if we want to get rid of any products inside the logarithm, we're allowed to rewrite this as the log base 10 of 5 plus the log base 10 of x. And we've, in a sense, simplified this. But I don't want you to think of this as something you always have to do. In this case, we took this condensed expression and we sort of broke it apart. But sometimes we might take this broken apart expression and we might wish to condense this. So don't think of this as moves you have to do, think of them as moves that you're allowed to do. So let's keep going here. Here we've got the natural log of 5x squared. So the natural log of 5x squared can be rewritten as the natural log of 5 plus the natural log of x squared. Now I couldn't do this before, but notice that now for this second logarithm, the entire argument is being raised to the second power, and so I can use that third property that says I can rewrite that as 2 natural log of x. So again, we're getting practice with these properties. The first one says if I have multiplication inside a logarithm, I can break it up as addition outside. The second one says if I have division inside, I can break it up as subtraction outside. And the third one says that if the entire argument is raised to a power, we can bring out that power out from the logarithm. So let's do one more here. We've got the log base 3 of 5 over x squared. We can rewrite that as the log base 3 of 5 minus the log base 3 of x squared. And just as before, while we couldn't do it earlier, now the entire argument in the second logarithm is being raised to the second power, so we can rewrite it this way. Let's try number 9 here. We've got the log base 10. Remember, that's an implied base 10. Let me just write it like this. I'll just write base 10 there for you. And we can go ahead and break this up. So we can first rewrite this as the log base 10 of a minus the log base 10 of b times c. So we broke up the division expression. Now we can continue further, but we got to be a little bit careful now with our grouping symbols. So I can write this as the log base a, and then what can I do with this logarithm here? Well, inside this logarithm I have a product. And we've said that products can be simplified as addition outside of those logarithms. But if I were to just write this, don't just write this down just yet, folks. If I were to write log base 10 of b plus the log base 10 of c, I wouldn't have the right answer. How come? Because I need to subtract the entirety of this expression. And so there's an implied grouping symbols that I have to remember to include here when I go ahead and apply that property a second time. Okay, let's try this one here. There's a few different ways we could go about doing this. I'm going to choose to do this way, but you can do it other ways. I'm not saying this is the only way to do this problem. But because the entire argument was being raised to the third power, I brought out that factor of 3. Then I'm going to go ahead and rewrite this as the natural log, or 3 times the natural log of x squared plus the natural log of y to the 4th. And again, what you see me doing here is you see me inputting grouping symbols where I didn't necessarily have any, because I need to make sure that this 3 gets distributed to the entirety of that expression. And if we continue, we could have 3 times 2 natural log of x plus 4 natural log of y. And this is not necessarily the best way you could leave the answer here. I'm going to go ahead and take it one more step and now distribute that 3 through and get 6 natural log of x plus 12 natural log of y. And I am not saying that this is the only way to do this problem here, folks. And in fact, I'm never saying that when we explore properties. The properties are your lists of legal moves that you're allowed to do, and I'm just practicing those legal moves as we work these questions here. So folks, I now want you to try number 5 on your own, and I will see you in the next video. Thank you very much. Bye-bye.